on 4.3, part 2. Okay? It's at least today and tomorrow. Wednesday, we just may be doing questions. I don't know exactly. But our job is to figure out how to use reference angles, which is a key in moving forward with trig. Okay? You use reference angles a lot. So we learned how to find reference angles. If you recall from part 1, reference angle is how far an angle is from the x-axis. Okay? So reference angles are numbers that are always less than 90, always positive, because it's just how far you are from the x-axis. So that's when we're adding and subtracting from 180 or 360, depending on the location. Okay? Now, what we're going to do is we're going to use those reference angles to find our trig functions today. So this is a type of trig we do, I'm going to say without a calculator, in terms of you're not just plugging in sine of negative 210 degrees into your calculator and letting it spit an answer out for you. Okay, as in this is, we use our brains to get there. Okay, now you might need your calculator to do some of the basic math to get there, but we're not using the trig function buttons. Okay, so there's kind of some steps here to help you think it out. Okay, first of all, we're going to figure out the reference angle. Probably along that same time, I feel like we figure out the quadrant, because that's you're trying to locate the quadrants, you figure out what your reference angle is. We're going to write out the answers to the trig function based on that reference angle. So our reference angles today are going to be 3 familiar numbers, 30, 45, and 60 degrees. Okay, and then we're going to put the proper signs. So remember, all students take calculus. We're going to use that to figure out which trig functions are positive or negative. Okay, so let's try this example 1. Now in this example 1, they ask us to find all 6. As we get going, you'll usually just be asked to find one of them. Okay, so we want the 6 trig functions of 315 degrees. So in other words, I want to know the sine of 315, the cosine of 315, the tangent of 315, and their reciprocals. Let's start by finding the reference angle. So 315 is not one for my chart. It's not one that I have memorized, right? But 315 matches up with one of those. Can you visualize where 315 is? Where is 315? Okay. 315, and as I said, steps 1 and 2 kind of go together, because I don't know how you figure out the reference angle without figuring out the quadrant at the same time. I just don't know how you do it. But so we, as we talk, so step 1 is figuring out our reference angle. Step 2 is knowing what quadrant we're in. Well, what quadrant are we in? We're in quadrant 4, yes? Okay. Back to reference angle. How do I figure out how far 315 degrees is from the x-axis? What is it close to? It's close to, in terms of x-axis, it's closest to the x-axis right there. And this is 0 and 360. What matters here is 360. Okay? Yes, it's 0, but I don't care that it's 0 right there because that's not what it's closest to. I care about the 360. So I want to know, what is this distance right here? So how do I find that? Okay, so this is going to be a scenario of 360 minus 315. And 360 minus 315 is 45 degrees. As I said, it's not that it's a no calculator day. We're not plugging in sine of 315, cosine of 315, and all of that. We're getting our exact answers. Okay, so we know that our reference angle is 45 degrees. We know that we are 45 degrees underneath the x-axis. We know quadrant-wise, as we are figuring that out, we are in quadrant 4. Okay? Now, step 3 says write out the answers to the trig functions based on the reference angle. So my reference angle is 45 degrees, right? So as we go through this problem, we're going to think 45 degrees. Okay? Even though what I'm actually going to write is I'm going to write sine of 315 degrees, cosine of 315 degrees, tangent of 315 degrees. And then I'll go ahead and write the others. Let's see. Reciprocal of sine is going to be cosecant of 315 degrees. Reciprocal of cosine is secant of 315 degrees. And reciprocal of tangent is cotangent of 315 degrees. Okay. And I'll have the chart on the sideboard filled out. So you're going to have to flip back in your notes, unless you have your chart memorized. Okay, but this is where the chart comes into play. This is where memorizing the chart is really, really helpful. But I know we're probably not there yet. So when I say, what's the sine of 315 degrees, I want you to think 45. So what's the sine of 45 degrees? Flipping back in my notes. I don't have my chart memorized yet. And I can look right there in 4.2 part 3. We had the partial chart we have filled out. Or we can go back to 4.2 part 2, where we filled out both charts. Are you tracking with me? Okay, so the sine of 315 degrees is equivalent in value to the sine of 45 degrees. The sine of 45 degrees is square root of 2 over 2. What's the cosine of 315 degrees? In value?
Wait, but isn't it 1 over sine, isn't it?
I'm not talking positive or negative yet. Okay? So, that's where I should have filled out.
Wouldn't the sine be 1 over square root of 2?
This is the rationalized version. 1 over square root of 2 is equivalent to square root of 2 over 2.
Yes, I was really, okay, yes.
Cosine of 45 is the same, yes? So cosine of 15 is the same. And as I said, we're going to come back and make some of these answers negative in a moment. Okay? Right now, I'm just kind of getting you to follow steps here. Okay? What about tangent of 315? In other words, tangent of 45 degrees, because that's how far it is from the x-axis, is 1. Okay? Cosecant of 315. Okay, I know it's cosecant of 45. And this is where I would say it's the reciprocal of 1 over the square root of 2, which is square root of 2. What do you know about secant of 315 then? It's also the square root of 2. What about cotangent of 315?
1.
The reciprocal of 1 is 1. Okay? Now, so we wrote out the answers to the trig functions based on that reference angle of 45 degrees. Our final step is to think about sines. What's our phrase? Or I don't know what your phrase is. My phrase is, all students take calculus. What matches up with quadrant 4?
Cosine.
Calculus, which stands for cosine. So what does that mean? Cosine, since we're in the cosine quadrant, cosine is positive. If cosine is positive, then we know secant, its reciprocal, is positive. Everybody else is negative. So negative sine, negative cosecant. Negative tangent, negative cotangent. Now, did I have to officially write those positive signs in? I did not. I just chose to make a point there. Those are your 6 answers to this problem. Okay? Now, on some of these, could you type in sine of 315 degrees on your calculator as long as you're in calculator mode and get that answer? You could get a decimal version of that answer, okay? But we generally tend to work with the exact answers. And I don't remember how homework will read, but we're looking for exact answers. So I'm not looking for you to punch that in on your calculator. I'm looking for us to use the chart today. Okay. Questions I can answer at this point?
No.
We're going to do a bunch of practice. And hopefully, as you get a little bit better, you'll be able to stay ahead of me some. Okay. Let's look at this next section. This next section, basically, we've got 6 different problems. We're not doing all 6 parts in each one. Okay? We're just answering for the one trig function. So like on A, I'm asking negative 210. So, sine of negative 210 degrees.
Is the same as 150 degrees.
Okay. Starting point is, my brain doesn't work in negatives as well. So let's figure out where negative 210 is. So how did you get 150, Katie?
360 minus 210.
Okay.
Negative 210 plus 360.
Which is what my brain would say. Same thing. Okay. So here's the deal. We're not quite doing reference angle yet. Because Katie just gave me 150. And I said, yes, I like that for a starting point. It's not a reference angle because it's not less than 90. But does it tell me where the angle is? It does. Okay. So the idea that if I take negative 210 degrees and I add 360, I'm going to get 150 degrees. If I throw a vocab word at you, that's a coterminal angle. Okay, it's just the equivalent angle. Same location, it's just going the positive direction instead of negative direction. Now, with that in mind, I need a reference angle, yes? So where is 150?
Quadrant 2. Like, yeah.
Are you with her? My picture may not be accurate, but it's in quadrant 2, yes? Because 150 is more than 90, less than 180. Now, if you are someone that your brain works okay in negatives, and you're like, I just want to leave it negative. Well, could you have done that? Does negative 210 put you right there? It does. Okay? You could, if you know enough to be like, oh yeah, negative 210, that'd put me a little bit past negative 180. That's fine. I'm not saying you can't do that. I just know how most people's brains work. Now, I need that reference angle. How am I going to find that reference angle? Yeah, if I want to know how far that is from the x-axis, I have to look at the fact that this was 150. This is almost to 180. In other words, that's what the x-axis is. So 180 minus 150 is 30 degrees. Okay. That is my reference angle. And 150 told me we were in quadrant 2, yes? So I have a reference angle of 30 degrees, and I'm in quadrant 2. So in order to do the sine of negative 210 degrees, here's what you have to ask yourself. What is the sine of 30 degrees in quadrant 2? That will give you your answer. Does that make sense? In other words, sine of 30, 30 is my reference angle. So now I'm going to my chart here. Okay? And then I'll need to think about, is it positive or negative based on the quadrant. So, first of all, what is the sine of 30 degrees according to my chart? Sine of 30 is 1/2. Everyone there? Okay. So sine of 30 is 1/2. Positive or negative 1/2?
Positive.
Why positive?
All students project
Okay. All students take calculus. So that means that this is a positive 1/2. If this had been cosine or tangent of negative 210, then we would be giving negative answers. Okay with that one? Okay. Try, as I said, try and stay a step ahead of me. Make sure we know what we're doing. Okay. We're starting to feel confident, and then, bam, she throws radians at you. Okay. Tangent of 5 pi over 3. And I'm not saying you have to do pictures for these, but I mean, pictures can be helpful. So my brain, when working in pies, I think I shared this last week, I'm thinking 1 pi and 2 pi. 5 pi over 3. Is it closer to 1 pi or 2 pi? 2 pi, because 2 pi is 6 pi over 3, and 1 pi is 3 pi over 3. We talked about that last week, right? Turn those 1 pi and 2 pi's into fractions, appropriate for the problem. So that means 5 pi over 3 is down there. Correct? Now, where is it closest to the x-axis? 6 pi over 3. 2 pi, right? Which is 6 pi over 3. So technically my brain is thinking 2 pi minus 5 pi over 3. But I'll be honest, my brain never even says 2 pi. My brain says, I need that fraction. So my brain says 6 pi over 3 minus 5 pi over 3, which is 1 pi over 3. And that is in quadrant what? No?
No, well, it's in quadrant 4. What do you?
Okay, oh, so I guess what I was asking there, not where is pi over 3.
Okay, yeah.
Sorry.
Oh.
I see what you're confused is. Maybe I should, right here, we figured out that this is in quadrant 4, right?
Yes.
I don't know. Pi over 3 is my reference angle.
Yes.
Folks, is pi over 3 one on my chart?
We just found the reference angle. Pi over 3 is our reference angle, which is this, but we want this is a quadrant. It's like this one right here. 30 degrees is our reference angle. But we could try to yeah, that was it.
What we were trying to figure out is how far, like, okay, so this time we didn't have to add 360 or 2 pi. This time we already had a number we could work with. This first time it was negative. We had to add 360 to get it to be something we could understand. This time, 5 pi over 3 was already between 0 and 360 or 0 and 2 pi. I just needed to know how far from the x-axis it was. Okay? It's closest here. We placed it in quadrant 4, so it's closest to the 0 and 360 mark, or in other words, the 0 and 2 pi mark. So it's only 0 if you're up going up. Since this is down, we're in quadrant 4, so 2 pi. So we did 2 pi minus 5 pi over 3. So 6 pi minus 5 pi over 3, which gave us our reference angle. Okay? So in order to figure out the tangent of 5 pi over 3, you have to ask yourself, what is the tangent of pi over 3, but with the sign of whatever quadrant 4 tells us. Does that make sense? Pi over 3 is our reference angle, so we're using that as our angle, which pi over 3 is the same as what degrees?
60.
Right? And we have that on our chart, don't we? So it says pi over 3. It's also 60 degrees. We want the tangent. What's my chart say?
Would it be square root of 3?
Square root of 3.
Okay.
And then the question becomes, positive or negative square root of 3?
You can't have a negative square root.
You can on the outside. You can have a negative under the square root.
Okay. Okay.
Positive or negative?
Negative.
Because all students take calculus. C says that cosine is positive. That means sine and tangent are negative. This was tangent, so this is a negative value. Ask the questions if you have them. Or if you're confused, tell me you're confused and I'll just try and replay it. Getting there?
Yeah.
I don't expect it to be all perfect yet. Okay? It's a work in progress, right? So, C. Secant of negative 3 pi over 4. Okay.
4 pi over 3.
Hmm?
Secant of 4 pi over 3.
No, that's not what you do the reciprocal of. The reciprocal of secant says that we will actually be thinking in terms of, we'll be using the cosine function to figure things out in terms of like positive or negative.
Cosine of 4 pi over 3.
We're not doing anything with 4 pi over 3. Okay, so first of all, let's figure out where negative 3 pi over 4 is. Okay. Do you want negatives or do we want positives? If we want to work in positives, let's go back to like what we did on A. We, first of all, before we worried about reference angle, we added a loop around the circle, yes? So in degrees, we added 360 degrees. That means in radians, what am I going to be adding? I'm going to be adding 2 pi, which is 8 pi over 4. So negative 3 pi over 4 plus 8 pi over 4 is going to tell me 5 pi over 4.
I was on the right track.
Well, you were saying thirds though too. You were
Yeah.
upside down,
Well,
which was throwing
Because
me off.
if you count, you can do 1, 2, 3, 4. I just didn't count going the other way.
Okay, now 5 pi over 4. That's good. I can think positively, but I need to know which quadrant that's in. I need to know what reference angle that is. So what does your brain think for 5 pi over 4? Okay. Why are we claiming quadrant 3? I wrote it, obviously I'm not disagreeing. How do we know it's in quadrant 3? Without looking at the chart, which I know some of you did. But how would my brain tell me I know that's going to be in quadrant 3? Because it's a little bit bigger than what?
1 pi.
1 pi. Because 1 pi is 4 pi over 4. Are you with me? 5 pi over 4 is very close to 4 pi over 4. So that's how my brain can say, okay, quadrant 3. Okay? So I do know, whoops. I'll just put it over here. That I am in quadrant 3. In order to find that reference angle, how are we going to find the reference angle?
5 pi over 4 minus 1 pi.
Okay. I want to know how far apart these are. So I'm subtracting 5 pi over 4 and 4 pi over 4. Well, technically, I guess, if I want to be, I'm subtracting 5 pi over 4 minus pi, but as we already mentioned, that's going to be 5 pi over 4 minus 4 pi over 4, which is pi over 4. Is that one of your reference angles? It is. Okay, that gives me confidence I'm doing something right if I get one of my 3 reference angles. So, in order to do the secant of negative 3 pi over 4, well, first of all, I don't know which way you want to think about this, but we're going to be doing the secant of pi over 4 in quadrant 3. How do we do secant? It's the reciprocal of cosine, yes? Oh, goodness. So, the reciprocal of cosine in quadrant 3. So, what is cosine normally? Cosine is normally square root of 2 over 2. I'd prefer to use 1 over square root of 2. So, it's just going to be, the reciprocal is square root of 2. Positive or negative? All students take calculus. We are in a T quadrant, but we're not doing tangent or cotangent. So I agree it is negative square root of 2. Thank you for giving me those extra seconds. I totally lost track of time, as you can tell. We will pick up in notes tomorrow. We've got a lot to get done, okay? Quiz is possibly Wednesday. If not, it'll be Thursday. It'll be one of those two.